Hey guys, we'll go ahead and get started this evening. I'd like to thank everybody for attending. Wonderful weather. Normally when we have these in January and February, it's 6 degrees outside and the wind's blowing 20 miles an hour, so a much nicer day than what we've had in the past. Bathrooms are down the hall. We do have some snacks and some drinks here, so feel free to eat those. I'm going to talk a little bit tonight about solar, our net metering, and also about electric vehicles. And so with that, Ken Raming, our manager of engineering department, has worked many years with Ozark Electric, was a consultant with Toth and Associates before that time, before he came to Ozark Electric. Ken has not only been a resource, obviously, for us, but for cooperatives across the state. And so he's going to talk a little bit about solar and net metering, what the requirements are, how it kind of affects our system as far as Ozark Electric. Then we're going to have Scott Mahaffey, our District 4 board representative, kind of speak to you. He has both solar there at his home along with electric vehicles, and kind of from a member standpoint and what he's done to kind of try to lower his usage as far as with those electric vehicles and also with solar. So we'll talk about that tonight. Very informal. If you guys have questions, please ask those questions along the way. We'll go ahead and get started, and I'll turn things over to Ken.
Good evening, everybody. We're going to dive into solar challenges at the distribution level. And just so I know my audience, how many people here presently have solar? I knew Scott did. You do? Okay, good. Everybody else doesn't, but is interested in it, thinking about it, just curious? Curious? Okay. All right. So we'll get started. We're going to talk about safety, number one. And we have some general information we'll discuss. We'll discuss the net metering application process, the things we look at, the things we check out when you send in an application. We'll explain the billing processes and how that works. And then at the end, we have some generation analytics that will just kind of show you. If you want to see numbers, I got some numbers for you at the end of the presentation. So we have some tonight. First and foremost, we want to stress at the cooperative is safety, right? We're working with electricity every day. Our linemen are working with electricity every day. It can be dangerous if you don't respect it right. So we always, always, always want to make sure that any of these solar systems installed are done so safely. And it's a three-tier safety. Number one, safety of our linemen, so that when they're out there working on our lines and maybe it's de-energized and maybe your solar doesn't shut off like it's supposed to and it's backfeeding, they have to be aware of that. So they now have to protect themselves from two different directions instead of just the one that we've done for 100 years. It's been a radial system, and we knew where the source was. Well, now that's no longer true. Sources can be anywhere, so we have to make sure they're protected from all directions. Safety of the system, so we need to make sure our system operates adequately when you're putting solar back on. And then safety of the public, safety of you. We need to make sure that when your system is installed, that you are protected and you are safe. Okay? So some general information. This is pretty simplistic, but this is how the solar system works, right? You have, let me get the right pointer here. You have solar panels on your roof that generates down to some sort of inverter that's going to take that DC that's created by the solar panels, turn it into AC to use for your house. Now ideally, we hope that you use it all in the house. That is your best opportunity, bang for your buck, is to use it, not to put it back out onto the grid. That is not where your advantage is. But if you don't use it, it does return out to the grid, and then we have to figure out what to do with it. Okay. Here's some numbers that we looked at. We are one of 17 co-ops on the CAMO family, and presently we are number 2 in the KMO family at about 6.1 megawatts of solar generation. We're standing right behind White River. We have some 627 net metering contracts today, totaling 6.1 megawatts. That's just a graph by substations. If you know what substation you're on, you can see how much solar generation is on your substation. It's not surprising that Battlefield, Clever, Nixa, it's all around the Springfield area. And then Mount Vernon is our fourth largest around this area. And then we kind of go back towards the Springfield area. So we have a high concentration around Springfield. We have a high concentration in Lawrence County. Not so much down by the lake or way up north. Those are far more sparse as you look at the other subs. A 1 in 5% rule. So this comes from the state statute that says the cooperative has to offer net metering to the members for a value up to 5% of our previous year's peak. So that number changes every year. But say we peaked at a certain number, 100 megawatts, let's say, then it would say we could allow up to 5 total. After you exceed that value, then we stop approving net metering agreements until those numbers change again. 1% is any 1% in any one particular year. So 5% total, 1% in any one particular year. Question or? No? Okay. So we haven't hit that yet. We're at almost 3.9% from our previous year's peak, which was, I think, 169, somewhere in that range. So we still got a little bit more room to go. The process. This first thing I want to talk about, and probably the most misunderstood part of this process, is a net metering agreement that you signed and executed is not a contract with Ozark Electric. You signed a contract with Associated Electric to buy and sell kilowatt hours. We are simply a pass-through. So when you, the member, puts some back on our system, we report that to KMO. KMO reports that to Associated. Associated credits KMO on their power bill. KMO credits Ozark on its power bill. And Ozark credits you on your power bill. So we are a straight pass-through. You are not buying or selling. You're not selling kilowatt hours to Ozark Electric. You're selling them to Associated. Does that make sense? Okay. Nitty-gritty of it, these are the codes and standards that we look at when you send in a net metering process. There's 4 basic things that your system has to meet. The first one is IEEE standard, and it's got a big, huge, long, giant name. What it really means is that's the standard that controls how the inverter has to operate. That's the standard that says if you lose connection to the grid, your inverter must shut down within 2 seconds. Goes back to that safety thing so that you're not backfeeding back out onto the grid. Okay. The ANSI standard is the voltage standard. That tells us what's the maximum voltage you can have at your residence and what's the minimum and maximum of that. And we'll see here a little bit, solar will actually raise your voltage rather than decrease it. And we'll talk about that here in a little bit. Of course, the big ones, the National Electrical Code, all your wiring, your connections, point of interconnection, all that stuff has to meet that. And then the National Electrical Safety Code, that's the one the co-op operates under. It basically says you need to have X feet of clearance from your solar panels to a power line or transformer pole or something like that. So those are all the things we look at when we get an application in. And for lack of a better word, this gets really wordy, but I don't know how else to do it. So the net metering agreement that we use, was derived from Missouri state statute. Co-ops didn't make it up. Solar companies didn't make it up. The lawmakers made it up and said, here's the rules you operate under, okay? And so that's what we do. For, number one, for systems of 10 kW or less, that says you do not have to have liability insurance. So what size system is yours?
12 or 13.
Okay. So you would fall in the second category that says over 10 kW, they turn it over to each respective governing body to make the rules. So the respective governing body that's going to set forth the safety, performance, and reliability standards for the co-op is your board of directors. So they have set the rules for the safety and reliability rules that have to be met going forward. If you'll see on the net metering agreement, this is a snapshot of it. It has in there, if you are over 10 kW, you must have at least $100,000 of liability insurance. So that's liability insurance to operate the system, not insurance to cover the cost of the system or the panels or that sort of thing. That's your homeowners, right? This would be a personal liability insurance that says you're protected up to $100,000. And why do we do that? Because what happens when something goes wrong? Co-op's getting sued, you're getting sued, right? Something goes wrong and they say you put power back on the lines, you're getting sued. So highly recommend that you get liability insurance if you're going to have one of these systems, even if it's under 10 kW, because that's the world we live in today, right? Everybody's going to want to sue you. The other point we talk about is testing. And that comes from the IEEE standard that says, well, we require an annual test that you make sure that your inverter shuts off within that 2 seconds when you lose power from the grid, right? We send out a letter asking you to send us those test results. You're supposed to do it each and every year, and then we ask for that log to see if you've tested it or not, right? If you haven't, then you need to go ahead and test it. But that is developed from the standard that says we as a co-op can dictate what that frequency is.
The owner can conduct that test?
They could if they know what they're doing. But in order to do that, you have to open up the disconnect switch and then you're facing 240 volts. So if you're comfortable with doing that, yes. But I don't recommend most people do that. I recommend most people either hire an electrician or solar company or something like that. We don't do it. One, for liability purposes. Two, we got 600 and something of them. There's no way in the world we could do it, right? So I tend to not recommend people play with electricity. And that's the line. I hear a lot from people that say, well, I never knew that. Well, it's in the net metering contract, bold, highlighted, and underlined, just like it is there. So if they say they didn't know that or can't see it, I don't know what else to do. But it is in there saying you must test this system. And it's for your own safety too, right? We get a lot of people calling up saying, hey, your meter's wrong. And we go and check it out, and our meter's perfectly fine, but their inverter quit working. And they had no idea their inverter quit working. All right? So helps you too if you go ahead and test your system to make sure your equipment's working properly as well. Additional equipment. So when we look at these things, sometimes there's additional equipment. We may have to install a bigger transformer to accommodate the solar. We may have to change some phasing, we may have to build some line, we may have to do all sorts of things to accommodate it, to make sure that it works, not only for you, but for your members as well, or your neighbors as well, right? So when we do that, if we come up with any of the costs, the state statute says those costs are your expense. Most of the time, the solar vendors will do it for you, but if we had to spend some money, we had to upgrade a transformer and it cost $3,000, we would invoice you $3,000 for that transformer. Okay. There's a shall there. It's not a if you want to. It's a you shall do it. The other thing we see a lot is the agreement must be certified by either a professional electrician or a professional engineer. They must sign a pre-construction portion of it that says, hey, this system is designed and meets all those codes that we talked about earlier, right? Then after it's installed, they have to sign it again that says it was installed per the plans and specifications and it still meets all these code requirements. Okay? So professional engineer is an easy one. Professional electrician can get a little dicey, right? So we consider if it's somebody that is an electrician for a living, and that's what they do for a living, we would take that because there's no license like in Lawrence County, right? The only license is around Springfield area. But if it's your brother's, sister's, girlfriend's, neighbor's friend that wants wired an outlet, that's not going to work, right? That is not a professional electrician. And believe it or not, I have seen those. So here's what happens when you send in an application. Top portion is the requirements that we have. We need a site-specific plan. So we need to know usually a site plan that shows where everything is going to be, where your panels are, your inverters, where the meter is, where the transformer is, all that sort of stuff. Wiring diagram, so all the wiring that's associated with that, with the right wire sizes, breakers, all that information so we can make sure everything is working right. Specification sheets for the inverters, the disconnect, and the connectors. Certificate of insurance if you're greater than 10 kW. Building permit, if you're in Greene or Christian County, they do require a building permit for solar installation. And then the pre-certification signed. Okay? We prefer that to be in a nice, semi-professional looking drawing package and not drawn out on the back of a napkin, which I have received. Needs to look professional and have all the information on it. Not something scribbled out on an envelope and say, here you go, right? So we take that and then we do what we call a PV hosting study. So I have a very detailed model of the entire Ozark Electric system, right down to your meter, right? Includes substations, lines, transformers, every piece of equipment out there we have modeled in there. And so what we do then is we take that generation that you're going to add and we stick it into that model. And we look at April or May usage. And you'll see when we look at the statistics, you'll see why we do that. Because those are the months, April or May, when if the sun's shining, your solar is going to be pushing out power. But we don't need it, right? No air conditioners running, no heat running, nothing running. So our system is at its lightest load. And then you try to push all this generation out onto it, that's when the bad things can happen. And so that's why we look at that and make sure under those circumstances that something bad isn't going to happen. If it does, then we give a bunch of options to say, okay, this isn't going to work, but maybe we could do this, maybe you could do that. Here's some options on how we could probably make this work, right? And so here's what the kicker is when we talk about this. The solar inverter is what we call a constant current source. That means if there's sun shining, your inverter is going to push out power, regardless of what the grid is doing. Doesn't matter. If the grid needs it, if it doesn't need it, if it has no load on it at all, it doesn't matter. That inverter is going to push out maximum power onto the grid. And so the trick is, what are we going to do with it? So if you think of that in terms of the water analogy here, that's pouring the 5-gallon bucket into the 1-gallon pail. It's not going to fit, right? And when it spills over, it makes a big mess. Same thing on the electric grid. When you push too much generation onto it, and it doesn't need it, and it starts spilling over in areas that cause problems, it's going to make a mess, right? So we try to avoid that and look at these things up front. Each and every one that comes in, we model this way to make sure that it will work for you, it will work for your neighbors, it will work for the other members on that line, and not give them some sort of adverse power flow. Okay? So here's what happens. So if you just think about, here's the substation, all right?
I'm sorry, can I ask a question?
Yes, go ahead.
Back to your bucket picture, so just so I can understand, so the sun's shining and you're pouring it out in that little bucket because you're not using it.
No,
But-
you're pouring it in there.
Okay,
You're
we're
not
pouring
using
it in there, our solar is.
All right.
But so if, like say we have a 13, but we've been approved for a 10, you're just not accepting part of that?
Well, we would have approved for whatever you submitted to us.
No, we have a 13, but you only approved for a 10. So I'm trying to figure out how the rest of that works. Where
So the
does
10 would fill up the small bucket. The other 3 would spill all over the place.
Okay,
Yeah.
okay,
That make sense?
yeah.
Yeah. I don't have anything to do with it. I can't use it. Nobody wants it.
So what do you do with it?
Well, there's the trick. Yeah. There's the trick. You have to figure out where it's going to flow and if you can use it or if it causes other problems before you can dissipate it. So if too much would probably rise the voltage up. And then we have to, like she said, we probably limited it to say you can install 13, but you can only export 10 onto the grid at any point in time because that's all they can handle at that location. And each and every location is different, right?
So what happens to the other 3? I mean, it just goes on the grid, okay. And does that have to do with how many solar there is around you?
Could. Yeah. Concentration would affect it. You know, where you're at on the system would affect it. Not every point on the system is created equal. So if you were on a 3-phase line close to a substation, you're golden. If you're at the very tail end of a 30-mile long feeder at the end of the single phase, different issue, right?
So I think a little bit of the question is too, the 13 kW that you're producing, if your home usage can use that 13 kW, it's being utilized by your home and wherever that would be.
Yeah, that's perfectly fine.
Being able to export it back on the system because of differences, maybe, you know, someone is just on a single phase line and it's way down the road here and you have 2 or 3 solar or net metering members, you're getting too much of that flow, so we have limited it to like 10 kW. So out of that 13, we can only put 10 back onto the system, 10 going back to the grid. But if you can utilize the 13 that you're producing for your home and your own usage, then you're able to utilize that.
You can put in 50 if you can use it. Yes, sir, Steve.
If there is 13, your house is putting out 13, you're only putting the 10 back out on us, on Ozark Electric. Isn't the other 3 just lost?
Well, it throttles the system down and it doesn't generate the other 3, it just generates the 10. That's how it works. The inverter throttles down and only does 10 instead of the 13. Then if you start using it again, then it'll throttle back up and pump it to you. But it will still only, the way we meter it, it can't go back out onto the grid. Right. So the inverter takes care of that by adjusting its output.
So Canada would have basically like a governor, in essence.
Right.
Like that.
Essentially a governor.
Yeah.
Slows it down, and then when you can use it again, speeds it right back up.
You can use the 13 internally, great.
Yeah.
You're ungoverned, but there's a governor between the solar system
And the grid.
Actually the large grid. Is that a fair?
Correct,
Okay.
yes. That's a good way to put it.
What would happen if 3/4 of your customers had solar?
They wouldn't approve it.
Yeah, because the system wouldn't work. The system would be a shambles. Yeah.
Thank you.
You're welcome. So here's what I'm talking about, the substation, the blue line there, that's our traditional distribution line. We've operated for 100 years. We leave the substation, we go out, it drops load, it drops voltage, our voltage consistently goes down, and we know exactly what it is at the end. But what happens when you put this generator in the middle of it is now you have some power flows in two different directions, and instead of your voltage going down like we anticipate, it starts going back up, and then it might start dropping back down again. So that's the havoc that it's going to wreak on you, is it's going to start generating higher voltages that we can't control. So we try to avoid that the best we can. Our regulators won't regulate that. Nothing we can do. So if you were doing that and then you drove your voltage up high on your neighbor, and your neighbor was up to 130 volts because your generation, nothing Ozark Electric could do about that. We can't fix that. The only way to fix that is for you to turn your solar down. Right?
And how do you do that?
Well, turn the solar down?
Yeah.
Well, we'd have to start talking about limiters.
Back up in July when the AC and
We'll just use the export limit within the inverter. I mean, the inverters all have an export limit setting that you can set. And we don't do it by time because we don't necessarily know the exact time, but it does it by how much we know we can take.
say through those months of April, May, you know, AC's off, you open the windows and not using it.
Yeah, those are the hard months. Those are the tough months for us to control it. Summer, not a problem. Not a problem. April, May, September, October is the challenge months. Okay? And I'll show you when we see the statistics at the end here. Okay? So that's the challenge we have, trying to control that voltage and make sure we stay within that ANSI standards, because those are the standards we have to follow, right? We have to be between 118 and 126 volts at your meter, and we have to do that with all this different power flows, and that becomes a real challenge. Getting harder and harder every day. With 617 of them or something now, getting harder every day. Any other questions on that? We'll talk about the billing process then. So again, the billing process is laid out in the state statute. It says you must use either 2 single meters or 1 bidirectional meter. We use 1 bidirectional meter here that measures forwards and reverse power flow. And then it also tells how we pay for that excess generation, again down from associated. It's their avoided fuel cost. And its avoided fuel cost is usually 2.5 cents a kilowatt hour. Unless you have some extreme weather. This past January, it was almost 9 cents a kilowatt hour, right? Because fuel was high. But normally it's down in that range. And why is that? Because one, Associated is the one paying you for it, right? We're just a pass-through. It has nothing to do with us. So we still have trucks and poles and wire and transformer and everything else that's built into your rates that is still there. The only thing that isn't there is Associated didn't burn the fuel to generate those kilowatt hours that you generated. So that's why they pay the avoided fuel cost. Yes?
Is it avoided fuel cost calculated hourly, monthly,
Associated calculates that monthly,
monthly? So as an average over that month? Okay.
whatever their fuel cost is for that month. And I got a slide at the end, I'll show you the historic stuff, right? Okay, so here's what we use. We have one bidirectional meter, right? It measures kW delivered, kilowatt hours delivered, kilowatt hours received. And then, of course, the difference in those two is the net kilowatt hours for the month. So that's what you see on your bill. And here's just 3 cases of how the bill would be calculated in 3 different scenarios, okay? So the first one is co-op delivered to the member 750 kilowatt hours, and we received back 200 kilowatt hours, okay? So your net is 550 kilowatt hours for that month, positive. I just used an average system-wide demand of 10, okay? So there is no credit because you're still positive, right? You would see an energy charge of $53.35, the demand charge of $37.50, availability charge of $35, for a total of $125.85. In the second case, you're going to net that out, and you're going to give us back the same 750 that we give you. So your net kilowatt hours is 0, right? Still have the demand, still have no energy charge, right? Still have the demand charge and the availability charge. So your bill in that case at net 0 kilowatt hours would be $72.50. The third scenario says you take 750 from us and you give back 1,500. So now you've gone into the negative net, negative 750, okay? Same demand. So now I'm going to take that 750 kilowatt hours times the voided cost, whatever it is. I've just used 2.5 cents, right? So you would see a credit of $18.75. No energy charge. You'd have the demand. You still have service availability. You still have $72.50 on the bill. And how this is handled, if you look at the bill, in this instance, if you look up here, this is June, and this individual put back 306 kilowatt hours back onto the grid. So we delivered 1629, they delivered 1934 for a negative 306, right? So you'll see your facilities charge, your demand charge, that's all there is. And you'll see down here at the bottom, credit, current accumulated net credit, $8.16. So we took 306 times whatever the avoided fuel cost was for that month. That's $8.16. That goes into what we call a bucket of renewable credit. Sits there on your bill, okay? Can't use it that month, but what happens the next month is, the next month they go positive again, right? And so he has a positive 836 kilowatt hours. So in that instance, you have the 836 kilowatt hours charge, you have the kW charge, power cost, but you'll see at the bottom, net meter credit, 816. So we automatically go in that bucket and grab whatever you have in there and apply it towards your kilowatt hours. Only kilowatt hours. You can't pay for demand, you can't pay for security lights, you can't pay for facilities charges. State statute says you can only pay for kilowatt hours because that's what you sold to Associated, right? So it automatically does that, goes in, grabs it, uses it, okay? If you don't need it and you go again the next month, it just keeps accumulating until you need to grab it. But the trick is, a lot of people want to put in a big giant system and build that credit up, right? they're only good on a revolving 12-month basis. So once that credit goes into that bucket, it's good for 12 months. If you don't use it in 12 months, zero's out and it's gone. So there is absolutely zero advantage to doing that unless you're going to use it, big chunk of it at some point in time, right? Because otherwise you're just giving away kilowatt hours if you do that. So I tell people, you don't want to build a system and try to build that bank up or think you're going to make money from the utility. The utility's never going to write you a check for that bucket of money unless you leave the system. All right? It's going to sit there. You're either going to use it at some point in time or it's going to zero out. Yes?
You got a demand charge there of 13.17.
Yes.
Okay, and is that the net that the member used during that month?
Yeah, that's his demand for that month.
They came to him regardless or her, regardless of the generation?
It's always going to be a demand. If you use any energy, there's going to be a demand associated with it.
Okay. But could the demand be less than what it would have otherwise been
Could be, sure.
without solar?
Sure.
All right, that was my question. Okay.
The best way to affect demand with solar is batteries.
I was just going to ask, did this agreement facilitate the use of batteries? Or could be used for
You could use batteries to offset that demand if you wanted to, yes. That's your best opportunity to do that, if you install batteries with it.
and that could be done under the existing agreement?
Yes.
Application.
Yeah, you just do it with the application. You just say, we're going to install this amount of batteries, so we know. You know, you charge your batteries up, you got it ready, right? And then when you want to use it at peak time, you just discharge your batteries to avoid that demand.
All right.
That's the best way to do it. Yes, Steve?
If an existing system wants to add batteries, do they have to do anything?
No, we just ask that you submit the plans to us so we know it. And then we document it that there's batteries there because we put it in all the databases and things like that. But
When you say peak time, just so we're on the same page, your personal peak time is what you're saying there. 'Cause we don't have a peak time.
whenever you want to use it, if you want to,
Just for clarity.
you want to turn on everything all at once, discharge your batteries to do that, right? Because Ozark's peak and your solar peak generation is at two different points in time. Solar is generating at its peak probably between 10 and 2. And our system's peaking over here between 6 and 7. So between 10 and 2, we're not peaking, you're putting back out. But over here, when we need it, you're still taking from us. So if you could use your batteries over here, that would help you avoid that number. Right? Right, Scott?
You bet.
Scott, I think I have more on that.
Oh, yeah.
Okay, any other questions? Okay, we'll wrap up with just some statistics here, and this is the graph I was going to show you when I was talking about the May, right? So the blue line is what Ozark Electric purchased in megawatt hours during the year. The red line is what solar members put back onto the grid during the year. And these are the interesting points. See, April, May, our system's at its lowest point, yet the generation is at its highest point. That's the part we got to tackle. And when we're over here in August at our peak, right, solar generation's at its minimum. So it doesn't occur at the same point in time. Again, that's the challenge of making that work in April and May. August is a piece of cake. April and May is a challenge.
Over a year's time, how much of the energy is solar?
I got another slide on that. I got last year's info. Might be right there. That's the amount of kilowatt hours Ozark has received from 2014 to 2025. So you can see it started out pretty slow, but from about 2021 on, it's ramped up quite a bit. We're starting to see it slow down a little bit now. I think maybe some of the incentives and things might slow it down, right? But it's ramped up quite a bit there. And then there's the avoided fuel costs for the last 3 years. They run pretty consistent, other than you'll see some spikes. You know, these are these January winter storms where you're up around $50 a megawatt hour. That's around 5 cents a kilowatt hour, right? Normally you're down in the $20 ranges, but every now and again you'll see those spikes. What was the one a few years ago, Uri? It was like $800 or something.
February 21.
Yeah, it was out of sight. But I think we had like 4 kilowatt hours put back on the system during that time frame because everybody was using it, right? And then here's your avoided fuel cost over the years. As you can see, that's the average for the year. Typically runs just in the 20s. You'll see a few of them spike up. You know, there's 2021, it was $57. That's going to be the storms as the gets really, really, really cold. The avoided fuel cost will go up because they're burning more fuel. All right. So kilowatt hours are worth more when it's really, really cold.
Does that local generation reduce your losses?
Say that, I'm sorry.
Does that local generation reduce your losses?
Not particularly. Because a lot of it's burned up in losses. Because I'm taking it from your side, I'm transforming it back up through the transformer to my line. That's losses. I'm transporting it down the line. That's losses. I'm going through another transformer to get to the neighbor. That's more losses. So you burn up a lot of that just in losses, getting it someplace else. Right. Our losses system-wide run them just under 5, right? 4.9% is what our system losses are. So we do really well with that. But I don't think this significantly impacts system losses. Everybody's favorite slide. Any other questions?
Can we appear on the website, your presentation?
I am sure it can. Yes, sir.
Yeah, so I'm not thinking about really sending stuff back into you guys' system. I'm thinking about like solar, if I got electric car, or emergency power and that. So is there much of a difference if I'm have a whole house battery, but I'm not going to be doing like this net stuff? I'm assuming I still need to contact co-op and let them know.
So you want to self-supply?
No, I'm like, yeah. I mean, maybe a partial set, like if I had a electric car.
So you could do a standalone system. You put in your system, you're all by yourself, we tear all of our stuff out.
No, I mean, it would be with, you guys, but I have solar included.
Well, then it'd have to be a net metering, because
Okay, so.
law doesn't allow you to have your cake and eat it too.
Okay, I just wondered.
Yeah. Can't have your cake and eat it too.
Okay.
But you could still do the same scenario. You just have to do the agreement, and what you would do is just set your export to 0.
Okay.
So you're not pushing anything back out, you're just using it all yourself, but you're still connected to us. We still got to go through the process, we still got to have the application, we still got to set up all the metering and everything. It would just be 0 all the time, but you could do that. Sure.
Do you have figures on what percentage of solar customers have batteries?
I do in my spreadsheet. I don't have it in the top of my head, but we track those in the spreadsheet. Fairly small. Getting a little bit more popular, but out of those 600, I would probably say less than 30 have batteries.
So at some point, magic technology will solve the holy grail of batteries.
Highly encourage batteries if you're going to do this. Because the way it's set up now, you're using the grid as a battery essentially. You're putting it out there, you're storing it, and then you're taking it back, right? But you can't take it back at the right time. And so you're far better off storing it in batteries and then using it when you want to.
Sure.
That's the best
I guess-
best way to do
I
that.
guess my question is at some point, I know there are co-ops and utilities, probably not in Missouri that I'm aware of, but, you know, the whole virtual power plant where you guys are able to reduce our demand peak, you know, co-op-wide by drawing off batteries. And I know you're not doing that now.
We're not doing it with batteries. We are doing it with a different system, though, called conservative voltage reduction. So we have the capability of lowering the voltage, which lowers your demand, which lowers our demand.
Within that range.
Within that range. We still have to stay within that range. So it's all fed into a computer, and it tracks it. And we got sensors out there on the ends of the lines that says, I can't go below this voltage at this location, but I want to put the substation as low as I can without putting this person too low and save as much demand as I can. But it saves your demand, which saves our demand, right? So it lowers your demand on your bill as well as ours.
Is that system active?
Yes, it is. We have,
A couple of us went to, is it, what did we have for the one Scott went to? Yeah, and we went to Austin for an RECA conference. There was some really innovative stuff coming out of Texas where they were using the batteries that they're describing to actually be able to pull back to actually help the demand components. Even when Scott and I were talking about the usage of EVs to actually help that. But I think like we've got a ways to go both in battery technology, infrastructure, and then I think it, just like Ken's saying, like the scale of people that are actually using batteries in our area right now is so small. But there's some pretty cool stuff. Texas is a really interesting area that they're really being pretty successful.
I think they only put them in Texas.
Certain brands, yeah. There are some certain brands that are Texas only.
There's co-ops in Colorado that have, you know, their own battery storage. So, you know, a co-op can do that in periods of low demand, high, you know, again, that would shave off that solar peak if we could charge batteries. You know, and again, those are board discussions. Obviously, the engineering and the board have to.
it's a little more complex in our world because of the three-tier system.
Right.
You could control a lot easier with batteries at your locale than we could, simply because we go through KMO and Associated, and there's a lot of layers and policies and all kinds of stuff you gotta make work in that. But the CVR project is active on 5 subs now, and it's working really well.
So can you say that in English then? Sorry.
The CV, conservative voltage reduction?
Yeah.
Yeah, lowering the voltage. We lower the voltage at the substation as low as we can without making your voltage too low. And when we do that, it lowers the demand, lowers your demand, which lowers our demand.
Which lowers our demand fees.
Yeah, lowers your demand at your house.
Wide.
The only way I change mine is by changing yours.
Right, sure. You know, I guess, you know, I would just be interested in the fact that we are looking at other places and talking about what's possible.
Oh, we are.
And, yeah, well,
It just
I'm not saying you're not.
It has to fit into that 3-tier system, and that's kind of the challenge we have in Missouri.
The one thing I would say about that is still though, renewables are putting back onto the system when they're not needed. Today is a perfect example. This morning it was below freezing. So by 10 o'clock it was whatever. Take you from the grid, take you from the grid. Today was 75 degrees, 74, whatever it was. Didn't use air conditioning, didn't use heating. Solar's really producing, but nobody's using it.
Well, that's my
So-
point with the
Right.
co-op itself, possibly even doing some battery storage.
I think we'd be better off at the individual. Texas, when we use Texas as an example, you have to realize Texas did not have the capacity we saw back in 2021, so they're trying to gain capacity because they did not have enough capacity to meet their customers' needs and, you know, for lots and lots of time there. So they're trying to kind of put a Band-Aid on that to where with our associated family, you know, we've had a generation of capacity to serve our members' needs during all these times. So I still think you have the imbalance if you're asking the co-op to do this versus doing it as your own.
It's much easier at the small scale than it is at the utility scale.
So when you talk about that lowering the voltage, you're not talking about like what I saw in the news where you're lowering people's thermostat. You're talking about lowering it the voltage, and what does that technically do to us as the customer?
Just lowers, makes you use less power.
By what, not heating my house as warm?
No, you still do the same amount of work. It might just take it a little bit longer to get there. Because demand is a rate. It's a speed. It's how fast you're using it.
Okay.
And so I'm trying to slow that down and make you use it over a longer period of time. Then your demand won't be so high. You'll still get the same amount of work done. You'll still get the heat. You'll still cook. You'll still do everything. You won't know the difference. You're just going to do it over a little bit longer period of time.
So is that essentially what you're doing when you don't use your like your emergency heat on your heater? Is you're not pulling as much, you're just heating over a constant time, or
Yeah.
do I have that wrong?
Well, if you're talking about strip heating,
Yes.
yeah, electric strip heating it will just nail you to the wall on demand because it's a short circuit. If you're using space heaters or strip heat for auxiliary heat, it will ramp it up. But if we have the voltage down, we can get that a little bit less, right? Your effect, you won't see any difference other than your demand will go down. That's the beauty of it. Yes, sir, Steve. Man, you got a lot of
What
questions.
is the voltage, your bandwidth on your voltages that you can do and still be enhancing standards?
We have it set at a minimum now of 119,
And it goes up to
126.
At the end of the line, they check to see what it is down there, and they use the information at the end of the line to go back to the substation and adjust.
Right.
To keep everybody.
So the standards gives you that range. It gives you 126 as a maximum. Doesn't mean you need to operate everything at 126 volts. Your equipment will work perfectly fine at 118 volts. In fact, the voltage at that outlet will work perfectly fine at 110 volts, right? So there's no reason to ramp it up way high and use more demand when we can lower it down and use less demand. Still within the same ranges, everything still works perfectly fine, just like it did before. You won't know any difference. If you're on Nixa 1, Nixa 2, Battlefield, Riverdale, Flat Creek, soon to be Clever are the ones that are running it. The voltage reduction.
Oh, so it's not system-wide?
No. We concentrated on the areas, let's say around Springfield, because those are our heavy loaded substations. We'll get our most bang for the buck. We go up to Dadeville, no offense to Dadeville, you're not going to gain anything at Dadeville, right? But you can gain a lot around Nixa, Mount Vernon, Billings. Those are ones we're looking at as well. The bigger substations are where we'll have the biggest effect. I got off solar, but anything else, or I'll turn it over to Scott.
I'll get you back on solar.
Thank you.
All right. Let's see here. It'll be a little bit of a refresher course for myself to see which slides I sent. We're trying to give, so again.
The other one, Scott.
Oh,
It's this one.
this one?
Yep.
Look at that. For those of you that don't know, my name's Scott Mahaffey. I am the board director for District 4, part of Republic, part of Willard. I have an Ash Grove address, live near Bodart. I'm going to try to give you the customer's perspective of the process. I'm going to show some pictures of my system, show you some pictures from the app that I use with my inverter to give you kind of an idea. Those that have solar, you've probably seen some similar stuff to this. Who all has solar again? You guys get solar? None on this side? Okay. Some that are thinking about it or whatever. Just kind of one of the things, like before I got into it, is just I didn't know what my expectations needed to be. What was I going to generate in a day? What was I going to generate in a year? Went through the process with a couple different vendors and talked about a couple different styles of systems. And at that time, just at least head down the path, I had one electric vehicle at the time whenever we went solar, okay, and installed a solar system. So let's see what we got now. So we're going to talk about solar from a member's perspective. I got some data concerning solar production along with EV and consumption and usage, and then ways to lower your demand when you're charging an EV. So how many, you said you've got an EV?
No, I'm thinking.
Thinking about it, okay. Any EVs? Oh yeah, you guys have got one, so, okay. All right, so this is my system, and those bills that you saw a second ago in Ken's, those were my bills. That was the 1 month this year that I actually overproduced for a month. Do what? Yeah, it's okay. My first year on the system, whenever I had this installed, I overproduced for about 9 months. So those avoided fuel cost credits, I was banking them, but I never got to the point, like Ken said, where I would get to a point where they would ever zero out. Because as you can see, I should have a slide for whenever you get to winter in our area. I have a decent sized system. I have a 16.4 kW system, 40 panels. They're on a ground mount out in my yard. And whenever I got this, the solar installer gave kind of an idea of what I should generate in a year. You know, based on some data they get from some government sites and things like that, where they track the sun, they track the area and stuff like that. And so that was kind of the estimation as far as what they told me I would see in a year. Now there is one difference that's on here. Let's see here. This tilt 26 degrees. As you'll see in a second, I made a last minute decision that I wanted to have a really tall system. I wanted to be able to park stuff under it at some point. And so the engineering got to the point to where the wind load wouldn't allow a 26 degree tilt. So they're actually at about 10 or 11 degrees is all that it is. So my system is really not optimized for our area. They do face south. I've got two inverters here. And it's, I'm trying to think of the height, what that is. I mean, it's probably 10 feet on this side and maybe about 12 feet on this side. So I can park. I haven't done it yet, but my kid, he's about to start driving and he's going to park. That's going to be his parking spot at that point. So
what percent or what tilt is that then?
About 10%. And so, and if you do some research, it's pretty flat, yeah. And so in the summer months, it's better. You know, there is kind of the 26 degree from my research is probably the best in our area. A little higher than that sometimes. You do better in the winter. You know, because in the summer when the sun's straight overhead, mine does pretty good. In the winter, mine does not do really good. You know, and adjusting the tilt would probably help that. But
How many panels is that?
40
On that?
on that, yeah. Yeah, it's about 54 feet long. It's probably the size of a semi-trailer. It's pretty big. My roof was not conducive to, you know, this shows you kind of the area. This is the south facing. I didn't have enough room on any of the south facing to do that, and so then I would give up some production numbers if I would put them on the east or the west or something like that. And my shop faces east and west, so it would do really good in the morning and not so good in the afternoon or something, or whichever one you pick. So I had the space, and so we went with a ground mount. So there's my system. So here's just kind of an up close of the inverters. They've got little cellular deals where they communicate to an app. To where I can check it, and it combines the numbers, and so I'll see you know, numbers of both inverters and stuff like that. Now what Ken talked about a second ago, where you may have a situation where you have an inverter that is not communicating and you may think it's the co-op or the meter or something like that. Mine, I've had a motor die, or inverter die. Oh, whoops, I think it died. Oh, hey. This one I've had to have replaced, and what I noticed on mine is like here's a good month in June, but mine was half of what it should be. In a sunny day and stuff like that, it shouldn't have been that way, and so I was able to determine that I had an inverter that died. So expectation-wise, here is what a curve looks like. You can kind of see production starts very minimal, you know, in that 6 a.m. range in June 21st of this year. sun just kind of starts creeping out, and you'll start to get, I mean, and on the app it'll read, it's making 400 watts. You have this huge panel and you're making 400 watts. And then it starts falling off again, summer and stuff like that. And this gets 8 o'clock or so, but it's very, very little. My 16.4 system, so just to give, again, expectation-wise, mine is not limited. The feeder that I'm on and the neighbors and stuff like that worked out well to where my system can generate and export at its capacity, at its max capacity. Whenever I kind of went into this, it's like, okay, I'm getting a 16.4 kW system, but I never saw it hit that. I never saw it get to that number. And at first there was some concern, like, hey, maybe my system's not generating what it should. But that tilt comes back into things. Did a little research. One day, I can't remember exactly what the day was, but I passed it. I passed 16.4. I went to 17.2. And I actually called somebody that was way smarter than me and just asked, why did my system just produce more than it's rated for? And it was a mildly overcast day. And you actually get some bouncing of the light, some reflection. Light comes down, hits the earth, goes back up, hits the clouds, and comes back a second time. And so there are instances whenever the system can produce more. And so that's one of those things that Ken has to look at is it's a rated system, but there are times whenever it may actually produce more. I've only had it happen one time, and it did it for about 30 minutes. It produced in the 17,000 watt section. So, but again, this is a daily production. On that day this year, my system produced 115 kilowatt hours. Yes.
Just looking at this graph.
Yep.
If I had that system installed at my place, I wouldn't be using almost none of that.
Nope.
During that time period.
Nope.
So I have two choices. I'm either trying to bank my credits back at the co-op, or if I was doing that, I'd really consider batteries.
Right.
Because that would take me completely off the grid for most of the night.
Yeah. So I get to work at 7 o'clock and I leave about 6 o'clock, typically. So you can look at that and there's not a whole lot happening at my house, yeah.
Following this gentleman's question, your 13.17 kW, what time of day does that occur? That was your sample. No, your demand on your bill. You said that was your...
That was mine, yeah.
What time of day did that occur?
Outside of this.
Almost always.
Yeah, it's completely outside of that.
That's the issue when it comes to...
Yeah. So if like Wayne was saying, if you had batteries, to where then, yes, you can fill the batteries, and then at night, discharge them. That 13 kW demand that I had would be substantially less.
Because you're going to get more payback from the battery offsetting your demand than what you're going to get credit from.
Yeah, the credits feeding back onto the grid at 2.5 cents is not a very cost-effective way to do it. It's either better to use it or store it. Let's see, we'll get into that here in a second. So let's see here. So here is a picture on the very same day from the co-op side. Here is my usage. And so this is my house. This is what I'm using, and then this is temperature, I think is what that is, right? Yeah, that is temperature. And then when these bars get in the negative below this line, that's when I'm pushing back into the grid. So you can see it's kind of the reverse of that image that I showed you a second ago.
It's the 10 to 2 time frame, right? Or 9 to...
Yeah.
9 to 3?
Yeah. Probably. On the bottom, yeah.
9 to 5.
Yeah, 8-ish, 9 to 5, somewhere around there. And I'm not even home. And on a summer day, yes, there'll be some AC running, not much more happening. And so at that point, I'm pumping power back into the grid to then capture it again at night. I will use up everything I produce. So I don't remember on that day. Does it say on there how much I used that day? Total? I don't
If
think
it's not, I don't believe just the...
I don't think so. All right, so here is a cold month. Here's a January 20th of this year, or of 25. And I kind of selected, so on my app for my solar, I can kind of select a time and it'll tell me exactly what I was doing. So 8 o'clock in the morning, I was making 1.74. Didn't quite get up to 12, where the one before I was well over 13, 14 kW probably that my system was making. But I'm almost half of what I produced in the summer I produced on that day in the winter. And these jagged lines and stuff like that, that's cloud cover. That is, because there's nothing blocking my panels. So the only thing that would block it at that point, unless there was snow, and I've got one of those here in a second, I think, too. So there's that day. As you can see, even in the winter, there wasn't a whole lot happening at my house at that day. At that time, my heat pump was probably running, and so less was going back onto. But the times whenever the solar wasn't happening, you can see I was using quite a bit. So anything above that is what I used, and anything below is what I put back. All right, here's another picture. So here is that same June 21st, that first one. I just selected what the peak was. I just went to 1 p.m. in the afternoon, 13.88. So on that one day we looked at a second ago, I had got to 13.88, and my house was not utilizing much of any of that. Every now and then, probably about 4, whenever my AC would kick on. But whenever it wasn't on, it probably wasn't using any of it. There is a winter, probably a really good winter day. That's January 12th of this year, of 26th. You can see that's a sunny day, and I only peaked at 9.72, where in the summer I was at 13.88. So the sun location in the sky, the tilt of the panels, that is that. The hours of the day widens the graph, but less hours of the day narrows it. And whenever you guys are talking about, as far as they've limited your 13 to 10, so it would look like a flat line at 10. You could put a 50 kW at your house and limit it to 10, and you'd have a lot wider footprint that would come up faster and then just level off like a plateau is what it would do. A lot of times they call that clipping. All right, so there's the 60 kilowatt hour day, winter. Here's that's a not so good day. That's December 7th of 2025, and that is either just a completely overcast day or maybe some snow cover on the panels. Just not a real good day. And on a December 7th, if it was cold enough, there's a possibility that I could use 300 kilowatt hours. And I'll get into that here in a second as to why mine would use that much. But whenever you have a heat pump and those resistive heats that we talked about a little bit ago, and it gets too cold, that resistive heat's going to use a tremendous amount of power. So on the days that I would need it the most, this is what my solar would be doing, or could be doing. So there's that day. So as you can see, there's nothing below the line. I produced very little, and I used a tremendous amount, and it had no real measurable effect at that point. So this is an app that I have. Some of you know, some of you, we've talked about it before. I have a program, or I have a system installed in my house it's made by a company called Emporia. It is a whole house monitor. It has separate CT clamps that will actually clamp onto different circuits in your breaker box. It has the ability of measuring 16 different circuits. So I can read kilowatt instantaneous, I can read kilowatt hour across any given amount of time, and it does it in real time. It saves the data and stuff like that. I've had that system for quite a while, since before I went solar. It's when I got it, and so this is just giving you kind of an idea. So those illustrations that we were looking at, this is on the co-op side. This is what they're looking at, and this is also viewable on the web version of Smart Hub, correct?
Yeah.
Yeah. So you can see this. You can see this. Log into the web-based version of Smart Hub.
That's a usage explorer.
Yeah, usage explorer.
You look individual days, months time, 12 months time, 24 months time, depending on how long you've been on the system.
On the system. Yeah. Yes.
You might just clarify, The numbers you're showing as production
Oh, yep.
are far different than those numbers that our meter sees.
Correct, yeah, so that's a good, so this production here, this 115 kilowatt hours, that is what, and as far as I can tell on my inverters, that is what mine produced in DC power. So solar produces DC power, and what we get here is AC power. And so the inverter changes that. It inverts it from DC power to AC power. And we're talking about losses, line losses, things. There's losses there. So where mine produced 115 or generated 115 kilowatt hours across the day in DC power, there's probably a 5 to 8% loss as far as once it gets to AC. And even on my own measurement in this app, I can see those differences. I can see where it says I'm producing, my solar app says I'm producing 10 kW, but on my house it says I'm producing 9.5. And then it all comes into the what your house is using at that given time. That's what the co-op sees at any given time. So if I'm producing 10, your house is using 3, the co-op only thinks you're sending back 7 net at that point. So that's why this number here at that time will not match what my solar app shows, because it's not, my solar app's not taking into consideration what the house is eating up. You know, even if you don't have a whole lot going, you'll have some little losses and stuff like that, and little things using power. And so yes, that's a good point. It's all right. So again, this is a similar graph with a program that I have on my own house and stuff like that, where I can look at usage the rest of the day. I can look at my generation. This is what I exported, and it's just one of those things to where I can monitor more at my own leisure at that point. The program does have a deal where it will give you your peak demand. It'll tell you what your peak demand is for the month. You have to kind of remember it goes on calendar days, where the billing cycles don't fall 100% on calendar days. Now net metering, I think everybody's on billing cycle 1. Is that correct? All of net meter. So once you go net meter, you go on billing cycle 1. And I will say it is pretty close. I think it's like the 3rd or 4th to the 4th. So it's almost an exact on the month, but it's not quite. It's not quite. So let's see here. So that was a day where my consumption was, I produced a tremendous amount versus what I used and stuff like that. And so my consumption for the whole day was only 25 kilowatt hours, where that day when I produced very little, my consumption for the day was 105.7. Here is since I installed the solar, tail end of 22. I only had a partial month of December in 22, and so these are each. This is in thousands of kilowatt hours, so megawatt hours. This is in thousands of kilowatt hours. So there's a couple of months. This is my very first 2024 April, like Ken talked about. You can see April, May, June. I generated almost 3,000 kilowatt hours across those months. That April was kind of a standout, and I don't 100% know why. That's the month I was telling you where I did peak past the system nameplate at like 17 kW. That gives you kind of an idea. It does stay relatively in the same arc. You will see there is degradation. And that's a known fact as far as solar goes. So as they age, they will produce less. As they get hot, they produce less. And it's not air temperature, it's surface temperature. So anything over like 75 degrees, they start reducing the amount that they produce. And so you think in the summer with the sun out, it's going to be the best time, but really it's those April times which is the best. Here is some of the same things done by quarters across the years. And my app that's got, based on that, the original estimation of what they thought that I would produce in a year, that's where those little black triangles come from, is where's the estimation. So it does give you kind of a warm fuzzy, like, hey, I did better than I should. You know, somebody did better than you should. And then this last one, it's like I did a little bit less, but there's for the full year. So as you can see, I'm producing less every year, and that is weather related. So I think I need a lot more data to determine exactly what it is, but I think it would probably trend down like that for the next, because it's just the degradation of the panels. They do start to produce less. Let's see here. So this is my first full year. And so if you remember that first slide, they said I would produce about 25,900 kilowatt hours. That is 25.9 megawatt hours. It almost nailed it. 25.5 for 24, 23.7 for 25. And comparing some of these tail end of the months and stuff like that, October jumped way down. You can have 1 month where it's just rain, or whatever. I don't remember how October was. I probably put it out of my memory, but apparently it wasn't very good for solar. So, any questions as far as my solar install or the customer side of things? Yeah.
Do you do annual or quarterly maintenance on the panels?
I need to. Whenever I made that last minute decision to make them a little taller, it's made it a little tougher. You know, they do a pretty good job. So whenever, I will say this, whenever I first put them in, someone made a recommendation to me to Rain-X them. And so I Rain-X'd them. If you've used Rain-X before in your windshields, it helps the water bead up and stuff like that. So I did put a product on them to where hopefully the rain and stuff would slide off of them a little bit better in the snow. I really don't notice snow hanging out on them too much. Dirt-wise, they could probably use a rinsing. So, but I haven't really done much of anything to them. Leaf blower, got the leaf blower up there.
That could explain some of the decrease.
Possibly, yeah, possibly. Solar goes.
Do you think the cost of them was worth, the savings was worth the cost?
It depends on how you use it. So this system, again, whenever I installed it, I had one EV, and so some of the months, the first year I overproduced for 9 months, and I did build up. I think my avoided fuel credit got up to about $99, and then the first cold month just depleted it. You know, the first cold month I got to. My house is all electric, and then I got an EV, and so I do use a lot of electricity. I learned a lot in that first year as far as the overproducing and banking those little bit of credits was not the best way to go. And I get to the point where it's like, and I had made plans. I had plans whenever I had that EV. I had plans for a second and then a third and stuff like that, which we eventually did. The best way to get your bang for the buck for each kilowatt hour you produce is to use it or store it. And I can't store that much. Some of those months I'd make 3,000 kilowatt hours, and if you price batteries, that is a tremendous amount of. There's no way to store that much. And so my plan was to use it. And as long as you can use everything you produce, then I feel good about it. But if you're just overproducing, just overproduce, and it won't be a good financial decision at that point if you're just building it to have a large system and overproduce. Best way is just to use it. Use the power you produce. So, any other questions on the solar? Yes?
Did you try calculating a return on your investment?
I have, yeah.
And?
Whenever I originally installed it, it was about 5 years, 6 years, or something like that. At this point, it's probably out around 10, 11 years.
To break even?
To break even, yeah. Yep, to break even. Now, the EVs help with that, I think. They can't take all of the credit, though, because they do a good job of using a lot of electricity. So my original calculations were me not being able to use all my power. And so as I added more usage, I can utilize more of the power I generate. And so that does help. That does help. If you're not using what you're producing, there's not really any financial benefit at that point. So So we're going to jump into, let's see here, we're going to jump into EVs a little bit. So the original EV I had was a little Chevy Bolt. Second one we got was a Tesla Model Y. The third one we got was a Tesla Model 3. And so this is back to my Emporia view. This is back to my own system at my house that will determine. This is one day. This is January 14th of this year. This is what I used that day. My whole house. And you can kind of see things are labeled. My heat pump used 20 kilowatt hours. Air handler used 3. Water heater used 10. The Tesla 3 used 29.2. Tesla Y used 17.2. And this does kind of show some net usage in from grid, out from grid, and stuff like that. And kind of how Ken said too, some of this will not match 100% with what the co-op sees, just because of how this collects data and stuff like that. But these are real numbers. Total usage for the day, that day I used 104, and you can definitely see 28% of my usage was the Tesla 3. And so that gives you kind of an idea. So if you're thinking about going EV and stuff like that, it's really those two vehicles drive a tremendously amount different of miles. I drive the Tesla 3 about 84 miles a day. My wife, then the Y, she drives 35 miles a day maybe. So that gives you kind of an idea of what usage would look like. Charging. So we're going to get into the different types of, the different ranges of charging. So each car is a little different. The Chevy Bolt that I had, there's not a lot of options on the dash to select how much charging you do. Did you have a question? Oh, I thought I saw it. Okay. Every brand's a little different. The Tesla has a little scale where you can set the amperage that you want it to charge on. That's what I was showing here. So my wife's car charges at 12 amps at 240 volts. The different chargers that are out there, there is chargers. There is cords that you can plug into 120 volt outlet. 15 amp outlet. The max you're going to pull from that is about 12 amps. That's the max you want to pull from that. That's going to be about 1.4 kW. So thinking about, we're all very well acquainted with kW and demand and stuff like that. So as soon as you plug that in and it's charging the car, it's adding 1,400 watts or 1.4 kW to your house. And it's a constant. It doesn't fluctuate. It's just dead flat. If you step up to that's a level 1 charger. You step up to a level 2 charger, which is what we use. I charge at 16. My wife charges at 12. Here is what that looks like in kW. So my wife's 12 is 2.9 kW. So as soon as it's plugged in, it adds 2.9. Mine, it's 3.9. The cars themselves will charge at a max rate of 11.4 each. So that is, you could charge the fastest they will take in power is 11.4. So we could set them at the max. We could plug both cars in, and my two cars would add 22.8 kW to my bill instantaneously. That's a good sound for that. So I choose not to do that. I choose to lean on the side of, I'd like a little bit better battery health for my cars, charge them at a lower rate, more of a trickle charge. After driving the cars for a little while and stuff like that, you get kind of an idea of how many miles you can go on 1 kilowatt hour. My car will do about 3.5 miles. My wife's car is about the same. My Chevy Bolt was about 4 miles per kilowatt hour. It takes a little bit just to kind of get used to what your needs are. 84 miles a day. I sleep about 10 hours at night. Do some fast math, and I came up with the settings that you see, 16. And I've played with it. I've had it down around 8, and I wake up in the morning and my car didn't top off. And so I bump it up to 10, wake up and it didn't top off. And so for my driving style and what I do in the distance, 16 works for me. It works in the summer, it works in the winter, it works for me. Everybody's going to be different. Does anybody drive more than 84 miles in a day to work and back.
Do you charge the 100% any?
I did last night because I was driving from where I live to work to here to wherever. And so today will be about a 120 mile day. And I didn't need to charge to 100, but I do every now and then. Most of the time I charge to 80, charge limit 80. It's a kind of a general rule or a general idea in the EV world. That's kind of a threshold that if you can work with that and you can stay under that limit, then battery health would be better. There are some different battery chemistries out there, like a lithium iron phosphate in some of the Teslas and Fords and things like that. They recommend the 80 and once a week to go to 100. And that seems really cumbersome to change that. So I stick to 80 most of the time. That is the max what I do.
Well, I'm OCD, but I don't even, if we do make a trip and go to 100, I try to get to 100 when we're getting ready to leave.
Yeah. And mine was at 100 this morning, and so, but I don't remember what time I plugged it in last night. But at the 16, it was 16 amps. It was enough to get mine there. Different vehicles have different size batteries. Your guys has a tremendously larger battery than mine, so it is going to take a little longer to fill it up. These cars hold 75 kilowatt hours. So if you drove it from top to bottom, that's what it would take to fill back up. And you can remember my good day in the summer with the solar, I created 115. So that day alone of my 54-foot long solar panels would not have filled the two cars if need be. But I don't use 75 kilowatt hours in a day. I use 29 in mine, and my wife uses 17 just for the average driving and stuff like that. So that's the KW. That's the instantaneous KW of what the EVs do as far as what I've got mine set at. And that wasn't what I always had them set at. Whenever I first got them, I plugged it in and I wanted the fastest thing possible. I'd plug in when I get off work, and they probably charged for about 2 hours while I was eating dinner and then stopped. And then the whole night they just sat dormant. And so as I've grown up around them and a little bit more and stuff like that, the idea to charge them slower, which is better on the batteries, and it's better on my demand. I'd still have the Chevy Bolt, and my kid's going to start driving, so at some point we're going to be charging 3 at the same time, and so getting that level down to where my KW is not off the charts was a goal. Because I think, like you say, Wayne, you can affect that a lot more if I can keep that demand down. That affects my bill quite a bit. So it hasn't come without challenges, and when you have a wife that drives one too, and you're over there playing with the app, turning hers down, and she wakes up in the morning and said, "Hey, my car wasn't full." It'll be okay. Just drive to work. You didn't need it. You didn't need the full battery, and that's the reality of it. You don't need the full battery every single day. So I do. I charge in a method called ABC charging. It's a phrase called always be charging. The assumption that when your car's plugged in, it's feeding the battery is incorrect. The cars are extremely smart. I don't know if any of these. So this one, battery heating for optimal performance. So it was a cold day. I don't know what day that was. So it's plugged in, and it's probably full charge or 80% charge, 212 miles, and you can see it's got looks like pieces of bacon. It's warming the battery. It's cold out, and so the house is doing that, not the battery is doing that. The car is going to do everything it can to self-preserve, but just let it be known it is using power. So I don't remember one of the days that I didn't drive my car when it was -1 or whatever days. My car used 10 kilowatt hours. I didn't go anywhere. It was plugged into my house. I wanted it plugged into my house because I wanted it to keep the battery safe and warm and all that. If I had unplugged it, it wouldn't have done near as much. It probably would have gotten cold. It would have used some of its battery to do that, but it wouldn't have used as much. but plugging it in keeps it healthy. So, yes, you had a question?
So Model Y have a heat pump or resistive?
Heat pump. So the Chevy Bolt that I have has a resistive, and it is, the winter is dramatic. It is a tremendous hit on the range. The Teslas have heat pumps. My parents have a little Volkswagen ID4 that has a heat pump. It does pretty good. Not quite as bad in the winter, but you will use more. It's just the physics of it. You will use more.
And so when you said your house did that, not the car, is that because that system you have in there?
No, it's because it was plugged in. So the car, I leave it plugged in at all times. If my car's home, it's plugged in. And even if the battery is not, I mean, again, it may charge for 2 or 3 hours, actually physically putting electricity in the battery. And then the next few hours we sleep, if it's cold out, it'll warm the battery. I mean, when you walk by it, it's a little strange. You can hear it whooshing water around. You can hear the fans going, and you're like, you know, what's it doing? But it's doing what it needs to keep the battery healthy. But it's using electricity. It is using power at times whenever you may not anticipate. So just let that be known that if it's plugged in, it's going to have a mind of its own, using power at different times. That was the last one of those. I didn't know what all I had. Yes?
Do you have the capability to run that off your battery back into your house?
No. No.
What would you have to do to do that?
So bidirectional charging is what that's called. There's only a couple of vehicles that do it. There's a Hyundai or Kia that does it. There's the Ford Lightning, I think, can do it, but there's not any bidirectional charge.
The R2 will be able to.
Will be able to. So the problem is like Ken was talking about, the software in the inverters, because that's essentially what you've got. You've got a generator. You've got a lot of power in your car, and when you plug that into your house, there needs to be some safety there for the lineman. There needs to be some safety for yourself. If the grid goes down, but you're pumping power back into your house, there needs to be some kind of something in there. And I don't know to this day if you can buy a bidirectional charger yet. I don't know if you can physically do it. I don't know that they're for sale quite yet. And there's a lot of red tape. There's a lot of things to go through just to make sure that it's safe. You know, they call it V to V, vehicle to vehicle. That's the F-150, I think, can do vehicle to vehicle. V2G, V2H, vehicle to house, vehicle to grid, and then V2X is supposed to do all of it. And I think it'll be really neat whenever it does it, but the net metering agreement, you know, is one of those things to where if you had one of those vehicles, you would almost need to probably sign up for a net metering agreement, because you would be have the ability to push power back into the grid. So there would be some policy things that would have to be talked about here and all that stuff when those do come out. But it's coming. It's been coming for quite a while. The R2, the Rivian R2 is supposed to be capable of it. There's a couple other cars out there, and it's all software stuff. I don't know of any of the Teslas that have the ability to do it. I think some of the General Motors, whenever I worked at a GM dealer prior to the body shop I work at now, and obviously I get to talk to some of the sales guys and stuff like that, and there was some, you know, scuttlebutt about different products that they were coming up with that had that capability, but it just hasn't quite hit mainstream yet. So, not to touch too much on dealerships, stuff like that, but if you're going down the path of thinking about EVs and stuff like that, and you do talk to a salesman that's trying to sell you a product, the speed of which it charges is probably a selling point. There are cars, that Ford F-150 that I mentioned, it has the ability of charging at 19.2 kW. GM's Hummer can charge at 19.2. There's a few other vehicles out there that will charge it at a tremendously high rate. And so if your mindset is, I need to plug this in and charge at the fastest possible, that you can kind of get an idea what that's going to do to your demand. You know, you plug in 19.2, as soon as you plug it in and it runs for 15 minutes, it just added that to your demand portion of your bill. My parents live in Springfield. They have a Volkswagen ID4. My dad had a Emporia charger, wired in, hardwired at a 60 amp breaker. His car can charge at 11.4 max, and he wants it to. He drives 14 miles a day to the golf course and back, and when he gets home, he wants it to just go zap and be full. And there's nothing I can do to change his mind, but that is what he wants. If the adoption of EV gets more widespread, if it ever gets to that point where there's more people, if that mindset will be highly problematic. The mindset that I'm trying to take is trying to just charge at the rate that I need. I don't need 11.4 or 19.2, for my car to be charged in 12 minutes whenever I get home from work.
If you don't take trips or go, we charge at 70%.
Up to a full 70%.
At home, we never
Yep.
go. And,
Yep.
and it's just when you go somewhere.
Yeah.
That's when,
Yeah, we took my wife's car to Texas, and we did charge to 100% the very first, when we left the house, it was at 100%. And then we never charged it to 100% again that whole trip. You pull into a charger, charge for 12 minutes, it gets to like 75, and it gets you, GPS just tells you to go ahead and leave. You can go ahead and leave now, and then you drive to the next one that it tells you to, and you pull into that one, plug in, go to the bathroom, charge for 12 minutes. That type of deal. So yeah, so the charging to 100 doesn't happen that often, and it's the more you're around it, the more you realize you don't need it to. It doesn't need to be that high. So, any questions on EVs? Any questions?
Never have one because you have to rely on GPS too much.
Yes.
And the other part that I don't think I'm going to be able to do is I won't be able to sleep 10 hours a night.
Well, I don't know that I sleep 10 hours, but I'm not in my car for 10 hours. It's sitting completely still. But well, hope you got some questions answered.
One question about solar.
Yes.
Since we're talking about salesmen and such, any advice to people who are looking for like solar, say what to talk to, about to companies you deal with? I've heard some of them are pretty shady and such.
Well, yeah. And I can't make any specific recommendations, but do your due diligence. I went through 3. And met with them all, and you can kind of probably tell from my personality I do a lot of research, and I hope you do the same if you go down that path. Reach out to me if you get something that sounds weird. You can reach out to me, no problem at all. Reach out to the co-op. Everything I've told you, they can probably tell you too. That's other than some of the EV stuff as far as just the personal experiences, but. Being here, this is good. I didn't do this. I didn't call the co-op before I got solar. I called a sales company and I got solar. And I started getting emails from Ken, as the process was going through of things getting approved and stuff like that. That was the correspondence I had with the co-op at that time was Ken's emails telling me this is approved, this wasn't approved, this needs fixed or whatever. And then the official sign off, and it can be commissioned, and they can turn it on, and I can start making power. Past that, I didn't reach out, but I should have. So you doing this is great.
My advice we always give is just talk to as many companies as you can, and remember they're there to sell your product. Again, don't try to match 100% of your usage and some different things like that. Because selling back to the co-op is not going to be good.
It is not, no. If we lived in the equator, I think it would be a lot easier. Those summer months, it would all look more consistent. But the further north you get, that imbalance just gets so far off of like my summer production of 115, 120 to my winter production of 60. But my winter usage is tremendously higher. Where, again, if we were living at the equator, it'd be a little easier.
Unfortunately, we've seen some bad actors within the solar community. Last couple of years, solar vendors went out of business. A large solar vendor down in northwest Arkansas has went out of business. So yeah, just do your research and do your homework.
If you go to the engineering page on our website and then go to renewable energy, there's a tab in there called questions to ask a solar vendor. And it's a long list of questions to ask that vendor to ensure what they're doing is right by you.
All right.
Does the co-op recommend any batteries, companies or anything like that?
No. They're not going to recommend any products. specifically as far as things like that.
No rebates for that.
The rebates come all through Associated Electric, and so if there was going to be a rebate, it would come, it's a pass through just like
But
the
it comes from Associated.
Associated. Correct. Yeah. Yep. Yep. All the rebates that are in place now, as far as the heat pump, like the dual fuel heat pump rebate and stuff like that, it all is a trickle down through from Associated.
But there's no rebates on batteries.
Correct. Correct.